So our position function is s of t is equal to this, and the first thing we want to find is the time of position of any points where the particle turns around. So we need to find the derivative, and we find s prime of t is equal to 6t squared minus 36t plus 48. And the first thing we see is that 6 is a common factor, and we can, is a greatest common factor of these terms, so we get 6 times t squared minus 6t plus 8, and then we see that 6 is t minus 4 and t times t minus 2, and so t is equal to 4 and t equals 2 are 2 points we want to focus on. So here's 0. So we plug in 1 and we get 1 minus 4 is equal to negative 3, and 1 minus 2 is negative 1, so so we have a negative times a negative, so that's positive, so it's the velocity is positive here. And then between 2 and 4 we have let's say the number 3, so 3 minus 4 is negative 1, 3 minus 2 is 1, so it's got to be negative here, and then above 4, so let's pick the number 5. 5 minus 4 is positive, times 5 minus 3, it's positive, so it's positive. So 2 and 4 are turnaround points, and so let's just go to red. So we have 2 and 4. So what is our position function at 2 and our position function at 4? Well, 2 is just 2 times 2 cubed minus 18 times 2 squared plus 48 times 2 plus 1, and our position at time 4 is just going to be 2 times 4 cubed minus 18 times 4 squared plus 48 times 4 plus 1. And I'll do this. I know I'm being timed. I have 10 minutes to finish this video. You get a lot longer to do that for your test. So here we have, let's do this one first. It's 16 minus 4 times 18, right? So what's up here? 18 times 4, that's 72, minus 72. 48 times 2 is 96, plus 1. So we have 97. 97 minus 72 is 25 plus 16, that's 41. So we have this 41 is our position there, and this one right here, let's say 4 cubed is 16 times 4, which is 64, times 2 is 128. So I'm just doing this one right here, 128. 18 times 16, let's do that. 18 times 16, that's 8, 4, 108. 180, that's 288 minus 288. And then we have 48 times 4, that's 192 plus 192 plus 1. And this one here is, so let's do 192. I'm going to take this one and add them together. 128. That's 0, 1, 2, 320 minus 288. We have to make sure we add 1 back. This is 32 plus 1, that's 33. So this equals 33. So there are points 2, 41, and 4, 33. This is a lot of our work is just in this one problem. I don't know how much time I have, but we're going to go back. We're going to go back and reference these things because the derivative is huge. So these are our turnaround points. What's the position, velocity, and acceleration of the particle at t equals 1? Well, we have our velocity function, s prime of t is equal to 6t squared minus 36t plus 48. I'm just rewriting these things. S of t is equal to 2t cubed minus 18t squared plus 48t plus 1. And our second derivative is our acceleration. So there we have position, we have velocity, and we have acceleration. And that's equal to 12t minus 36. So we need to just put in, right, I said at 1, so we need to find s of 1, s prime of 1, s double prime of 1. So 1, 1, 1, 1. Now we just have to be super careful about evaluating, 1 cubed is 1. So s of 1, s of 1 is equal to 2 times 1 cubed is 2 minus 18 times 1 is 18 plus 48 plus 1. So our position is 48 plus 2 is 50, 51. This is 33 meters. S prime of 1 is 6 times 1 squared is 6. 6 minus 36 plus 48. So this is 18, right? So 48 plus 6 is 52, minus 36 is 18. 18 meters per second. S double prime of 1 is equal to, well, that's easy. 12 minus 36 is a negative 24 meters per second squared. Okay, we are almost finished with this problem. Might require a second video. I don't know if I'm going to be cut off any second. So what about the graph of the derivative? So we looked at s prime of t. What's the graph look like? Well, we know it's a parabola, and we know it's opening up. Right? I'm just going to look at it right here. Okay, ignoring these where I subbed it in. It's 6t squared minus 36t plus 48. Right? So this is a parabola. It definitely opens up, and we already found 0. We found some zeros. It definitely crosses the x-axis at 2 points. So s prime of t has to look like this. This is the only graph that the derivative the derivative of the position function can look like. All right. Let's continue on here. I'll recopy some things as necessary, but here is the next part. Hopefully I don't get cut off, because I really want to get to the extra credit. So we have, what is the total distance that the particle travels? And I don't want just simply the displacement. Well, remember, it turns around at 2. Oh, and this is from 0 to 6. I'm going to stop and I'm going to pick up again because I'm afraid I'm out of time.